Hey everyone, welcome back to another session by K21 Academy. And in today's video, we will be giving you a holistic overview of exam preparations of DP-203 Domain 1. We have a clip from our expert trainer, so let's get into the video.
So let us quickly summarize some domains that you should keep your watch on, and let us move ahead. The first domain is design and implement a data storage. The exam outline: design a data storage structure. First of all, tell us what service will you use. You have to be aware of it. When will you use blob storage? When will you use data lake? When will you use your Synapse Analytics dedicated SQL pool, Synapse Analytics serverless SQL pool? Okay, when will you use Azure SQL database, right? All of that has to be clear to you, first thing. Second is internal to the service, your knowledge. When will you use blob? When will you use queue? When will you use files? When will you use table? When will you use disk? When will you use a ADLS generation 2? What does ADLS generation 2 gives you for which you want to use it, right? Internals of the service, why do you use it? Then the configurations that you have learned about them. How do you configure them for security, RBAC, the POSIX ACLs, right? How do you create containers? What are the different levels of container? Private container, blob anonymous, container anonymous. What are the different kind of blobs that you use? Why would you use that one? So you have to systematically link your knowledge, right? If your knowledge is systematically linked, answers are so easy that you will be out of the exam after 1 hour. This is my guarantee. Generally what I'm talking about myself, my experience, I generally finish exams in 1 hour, 1 hour 10 minutes, 1 hour 20 minutes at maximum. The maximum time that I have took for an exam is 1 hour 20 minutes, and that was DP-201, right? Designed the data solutions on the Azure. It was a very hard exam, DP-201, because it was for solution architect data and AI. Some people believe that it is only for data engineering. No, it is for solution architect data and AI, right? It is a one of the topmost role, solution architect data and AI, right? So it was a very hard exam. So you have to link the knowledge, aware about the services, knowledge about the different offerings within the services, what are the different service level objectives within the service, and how do you end up using them. And that usage working knowledge is primarily what they will probe you on, is the practical knowledge that is for the labs. Design a partitioning strategy. Now the partitioning strategy will apply to two services, primarily 𝐊𝐧𝐿 DB, and this partitioning strategy will apply to the tables that we create in the Synapse Analytics, right? They're going to ask you partition range left for partitioning, range right for values, and range left for values. And in your lab itself, it is itself mentioned, even if you do not understand what really happens when we say range right for value and range left for value, is that if you have the time series data time column, you're going to range right, and if you have any other data, then you have options right or left, but you generally do left in that. Okay, we had discussed in our course where the meaning of range right and range left. Designing the serving layer is very crucial. That how do you create your dimensionally modeled table in Synapse Analytics? How do you end up using Azure Analysis Services? And earlier this course also had Power BI. Okay, this course had two labs on Power BI, lab number 16 and lab number 17. But Microsoft basically then said that it's too much for people, right? That course will run for eternity then. Physical data storage, implement logical data structures, serving layer. So let us talk about it. Synapse Studio. Synapse Analytics is the majority of the material of DP-203 exam. Synapse Analytics. Synapse Analytics is going to be a very, very important service in the future, right? Obviously, there are so many different tools available already. Snowflake is there, right? And Google BigQuery is there, right? You have the Amazon Redshift is there. Synapse Analytics if you have mastered Synapse Analytics, it is a second to none skill, right? You can basically defeat so many different competitors by having Synapse in your bank, right? So please be aware of what Synapse gives you. This we have already discussed, so I'm not going to go into technical discussion. I'm going to give you the guidance, right? Technical discussions already have been performed. Guidance is always be aware of provisioned, that is your dedicated mode, your serverless mode. What can you do in the serverless mode? What can you do in the dedicated mode that we had discussed? Synapse Analytics gives you data warehouse creation. Synapse gives you big data engineering through Spark, and it also gives you exploration. And it also provides you the data integration layer that you want, right? You want to stitch pipelines, you want to stitch data flows, you want to create so many different data pipelines for your modern data warehousing need. All of it can be done here. And you have to aware of its meta store that we created, right? Views we created external tables, we created external data stores to interact from external stores. And we also talked about security. We talked about row level security, column level security, dynamic data masking properties, transparent data encryption, always encrypted properties. So what I want to tell you is that keep your focus on those topics and try to go ahead. SQL, structured query language, is fundamental, right? They're going to ask you SQL in the exam. I don't want to lie. What they will ask you, I will tell you, right? Not more than that. Okay. They are not testing your SQL knowledge. They want to just test your SQL knowledge in the context of what you have learned. Cases, right? The SQL case clause, open row set, reading multiple files at a time by passing the stars, right? So whatever you did in your lab, no, they're going to ask you that. That's what I want to tell you. Data integration is a very important part of a data engineer's life. Companies have various departments. Every department, depending on their needs and their working methodology, records the data into different things. Some record it in Excel files, some record it in a CSV, TSV, JSON, some record it in databases like SQL Server, Oracle. Some go for visual files, invoices, PDF, product manuals, sales manuals. So what you see that every company has a different varied types of data that is sitting in their organization. And when they want to do some kind of business intelligence on top of it, they would like you to centralize it, right? They would like you to have something that helps them bring all of these things to a single place. And for that, you have to do data integration pipelines. And Azure Data Factory, Azure Synapse pipelines will help you do such ingestions in the batch mode, right? And obviously, by now you should have understood that whenever we stage anything in the cloud, data lake is the solution. You have to stage it in the data lake. If you go to any project, when we work in a project, the first stage of every project is dig a lake, let alone everything later. We're going to do everything later. Okay, dig a lake first of all. That's what it is called as, right? Dig a lake. And then the lake has various levels of refinement: raw lake, curated lake, conformed lake, processed lake, delta lake. So many different forms of lakes, process lakes, life cycle of a lake. That much we don't need. You will see it in your practice when you will do the practice, but you must have developed that thought process by now, that you're going to storing it in the data lake on Azure. Synapse Spark can help you do preparation of the data, as you know, as we have seen, JSON handling and all of those complex file handlings in Spark. And serverless will help you explore the business significance of the data, right? Your business team, business intelligence team might be asking certain questions from the data, and you want to check whether we can answer the questions from the data that we have staged in the data lake by initial exploration. If you're asking revenue and revenue growth year on year for this kind of product vertical, we need to get the data of that product and its sales so that we can answer such questions, right? So we're going to have to explore what we already have, then check the readiness of the data for quick readiness of the data in the serverless SQL pool, where it was going to give us open row set bulk provider operations using which we can quickly go ahead and do petabyte scale exploration on the fly. And then later we can take it ahead and do that. Model and serve SQL pools, which means the structured data warehouse will help you model and serve. Spark link is a very important. Your question, your exam will ask you about the link. Okay, link is what? Synapse link, right? I'm not going to go from scratch on each topic because you discussed all of this. Synapse link, okay? Hybrid OLTP. Earlier, this course also had some Power BI thing, but officially then Microsoft told us that you should curtail it because it is becoming too much for the learners, and we give it as a challenge left to them, and they can obviously ask afterwards. You should be aware about the significance of a data lake. Why did you create a data lake? First of all, here data lake will not come. This slide has certain problems, right? Here you're going to say, here what will come is blob store, right? Here you will see blob store, okay? Just apologies for that. Here you will see blob store, right? Basically blobs, binary large objects. It has a blob endpoint, blob.co.windows.net, and we use the driver WASBS driver, Windows Azure Service Blob over SSL. That driver is not file system aware. That driver is flat. That driver does not know what do you mean by a folder, what do you mean by pruning, what do you mean by predicate push down. Nothing. It is for serving. Take a URL, serve it on the website. That's it. Tata bye bye. Right? If you want to do big data analytics, it's not good. So you should do big data analytics on ADLS Gen 2. Okay, faster performance you will get because it has file system aware operations using the ABFSS driver. Okay, so you can use the ABFSS driver for that, Azure Blob File System over SSL driver, and the endpoint that is used for that is the DFS endpoint, distributed file system endpoint. Okay, which gives us higher performance characteristics. There were some we identified in our course that there are some shortcomings of data lake. Data lake has no answer for concurrent writers. If there is a single file and multiple big data processes like to process the same file at a time, there was no method called as concurrency control. There was no method called as protection from overwriting, right? There was no method of basically handling corruption, right? So concurrent big data processes may go in a race condition and may corrupt your company's data on the data lake. That's why we wanted to add some kind of asset compliance on top of it, atomicity, consistency, isolation, durability, and that can be done by the data lake engine that is already implemented on most of the existing data lakes like HDFS from Hadoop, Azure Data Lake Generation 2, Amazon Storage S3. Delta Lake has a lot of advanced feature. This course was not primarily on Delta Lake, otherwise we would have seen advanced features like the version transaction log, time traveling, Z ordering, partition pruning in detail, and we would have seen schema evolution, schema drift management. But we only saw how to consume it, how to eventually drive business from it, working knowledge, right? Those technical things will be good for a technical data engineer, right? But how you use it eventually is by the refinement processes in the streaming plus batch. As I told you, if you ask a data engineer what is your dream, he's not gonna say I want to earn $1 billion and then enjoy the life, leave everything and enjoy. No, the dream of a data engineer is to build a single pipeline that does both streaming and batch with full reliability, with full fault tolerance, with full concurrency and performance. Single pipeline I want to make a single pipeline that's going to do everything. And the lab number one was certainly in that direction, that told you do stream and batch in a single pipeline and take it through levels of refinement from bronze to silver to the gold. And then the gold will eventually contain your business aggregates on which you want to report. You saw this entire system, Delta Lake architecture. Okay, so go through the Delta Lake architecture lab again, okay, and understand it again, what you did over there and what is the business significance of what you did, right? I generally tell to people that basically what we do in technology is at the end of the day is business, right? Whosoever is the billionaire in this world is an engineer. right? True or false? Most of them, right? Most of the billionaires on the top ranks are engineers, right? Technological minds who created a business out of what they do, right? Because an engineer can do everything in this world, right? So you can see that delta lake over here. Dynamic file pruning is a very important part of your efficiency. We saw in a Cosmos DB that when you partition your documents in Cosmos DB, if you use the same partition key in your filters, that is called a static pruning, right? So whatever the key on which you have partitioned your documents, that same key you are using for filtering. So that will give us the good performance, that will give us dynamic, that will give us static file pruning. We will be able to identify your data very fastly because we can hit the partition, because the filter clause contains the partition key. But if you use the filter clause with a non-partition key, the key which is not your partition key, right? Then how can we make sure that we could do something for you, and we could go ahead and basically minimize the problematic situation, right? So if you observe, this is a dynamic file pruning format, which means end result of a dynamic file pruning. This is just a diagram, and I also took some time to understand it. Basically I knew it, but I couldn't understand where this came from, right? Basically, see, what is happening in this is the dynamic file pruning. If you do not use dynamic file pruning in it, you do static file pruning in it. Here 3 rows are coming after scanning 3,60,000 rows. So after scanning 3,60,000 rows, we are just getting 3 over there. Okay, we are just getting 3 over there. And if you look here also, we are scanning, but we are also using this filter at the runtime, which is filtering this key SS item SK in this 3 rows. So the output of this filter we are passing to the internal scan that is happening. Because if we do not pass this filter clause to this scan operation, which is the output of this filters clause, then it will also do a full scan of your files. Here you are joining on item SK. If you do not use this information, that after scanning 3,60,000 rows, you only got 3 rows from this filter. If you can pass dynamically at runtime this information of the output of this filter, which will only be available at the runtime, what is the output of this filter, right? If you pass this information at runtime to the internal scan that is happening over here, instead of scanning billions of rows, we will bring it down to 66 million, right? So earlier, if you do not use this filter, if you do not pass the dynamic information here, that this resulted only in these 3 rows, 40, 41, 42, then it will take billions of rows as a scan and eventually give you 40,000 rows. So it is like scanning an elephant but returning a rat. So if you could already tell me that it is a bigger version of rat from which I have to convert into a smaller rat, that would be fine. Don't give me an elephant, right? That's what dynamic file pruning does. At runtime, we can receive the output of certain operations which can assist us in reducing the scanning, unnecessary scanning of the files, right? So this information we pass here so that it also knows that it only has to scan 40, 41, 42, thereby reducing it to 66 million rows, and then eventually this joining clause eventually gives us 50,000 rows. If you do not use dynamic file pruning, this scan will take billions of rows and then eventually return just 48,000. That is scanning an elephant, returning a rat. We don't want to do that, right? If you want to read more about it, there is a very nice article. Here it is, and this is taken from this official article. Let's see this, and it's with, if you do not use this guy, dynamic partition pruning, if you do not use this information here, you use this method, it will result into these billions of scans. Static file pruning without dynamic pruning, right? So you can keep it, okay? In your exam, they're not going to ask you this much, okay? But they can quiz you on what would be your method of optimization. Okay, what would be your method of optimization? They can certainly ask you that, right? So what I want to tell you is you're gonna have to do some little bit scrutinization as well. Okay, you have to do some little bit scrutinization as well. I was learning machine learning, right? You know that. Dynamic file pruning. Organize file structure for analytical query. Always be aware that what kind of tables are created for what purpose. For raw data, what kind of tables are created for query table and joining tables. Silver tables are created, and then gold tables are created for business aggregates. Let us discuss quickly one sample exam. We have a lot of slides, so I will just quickly take you through these slides. You're designing a storage solution for a big data pipeline. The solution must meet the following requirements. Can store an unlimited amount of data. This is enough to answer this question. This all is not required, right? This all, whatever this written, no, this is not required at all. This is enough to answer this question. Can store an unlimited amount of data from these options. From these options, unlimited amount of data is only supported in ADLS generation 2. All other have a soft quota and the hard quota as well, right? But see this, ability to run massively parallel analytics, organize object files into a hierarchy of directories for efficient data access. Who does that? ADLS Gen 2. So primarily this option, that is organizes objects and files into a hierarchy of directories, will help you answer the question, because HNS is available in data lake. So I don't want to give you the answer of this question. I want to give you a framework of answering questions. Your basic knowledge will be tested by Microsoft, right? Minimizes the costs. Okay, Cosmos can also do all of this, but it may not give you unlimited amount of data, because the service that has unlimited restriction is only the ADLS generation 2, the data lake of the organization. Others have soft limits and hard limits for our usage. Okay, ADLS Gen 2. Your company requires an architecture which enriches data through a unified pipeline. Okay, that allows you to combine batch and streaming. Okay, fine. Enrichment process for both streaming and batch. I know that for streaming, enrichment processes, delta architecture should be used, which means incremental arrival of the data must be enriched through delta architectures. If data is incrementally arriving and you want to enrich it on the fly, best would be you go with the delta lake architecture for that. Okay, because your lab also told at the bottom in the summary that delta lake architecture is very good for streaming scenarios, right? So what we want you to develop is not this is the right answer. No, rather than knowing the answer, you should evolve your thinking capabilities, your analytical skills. Because if you enable your analytical skills, you will understand that how Microsoft asks questions. The secret of not failing any exam is analytical skills, right? If you have analytical skills, you'll be able to quickly sail through it. Design a partitioning strategy, horizontal partitioning, which is called as sharding, right? You can create a hash sharding. So here we are sharding out it on A to G shard. So whatever are the keys on the basis of A to G, right? So it may be converting it to one of that column may have been taken, and from A to G we had sharding it here, and then from H to Z. So H to Z we are sharding it here. So this is sharding on the basis of this column in a lexicographical fashion. But generally how sharding occurs is on the basis of the hash computed on a key, and then you can shard it horizontally. Why sharding is done? Why are you doing sharding? First of all, what is the reason? It could have been physical sharding. I'm not talking about physical sharding or logical sharding. We are talking about sharding. Why are you doing that? Why are you keeping everything in a single storeroom? If you visit any mechanical shop, right? If you look at these mechanics people, right? They keep their tools organized into separate boxes, right? Separate boxes for separate kind of a tool, so that when they want to resolve some problem for which a certain kind of a tool is required, they go to only that box. They don't have to scan, they don't have to basically scan an entire large box and somehow grab that tool and somehow go there. No, they're going to organize. Okay, I'm going to organize. These are the different partitions. Data is here. So if you ask, you tell us certain information that will help us know where we have to go, we're going to go there and bring you faster access, right? So you are sharding it, right? So that horizontally. You can also partition it vertically. Vertical partitioning is good for time series analytics, right? We generally do vertical partitioning when you are doing time series analytics. The reason being that your relevant information in the snapshot of time can be gathered through the projection on the columns rather than on the filtering on the rows, right? So when you do any snapshotting, you do generally on the projection on the columns, right? So remember, vertical partitioning will happen mostly in the time series data. Functional partitioning can also be done. Functional partitioning certainly means that a single partition serves a single business objective of the organization. So if you have an entire corporate data domain of the company and it contains the data of multiple entities, then you would like to do functional partitioning, whereby you may maintain in a single partition data pertaining to a single business objective. And the term business objective here is very vast, right? It depends on the company to company that what data according to them is satisfying, is good for their single business objective. Create a table in Azure Synapse Analytics. We have seen this already in action, so not going to go into the technical details, but I'm going to quickly highlight that when you create your tables, always remember that tables either will be fact or dimensions. You're going to have some schema for them, okay? And certain data types will not allow you to create certain indexes. So your lab mentions that. If you thoroughly read your lab, it's mentioned in your labs, right? For instance, here we are creating a clustered column store index. Certain data types does not allow this to happen. So they're going to give you deliberately while creation of the table. That's how they're going to ask you question. They're going to give you deliberately that here is the data type of these columns. What is wrong over here? Which is the valid index that you can create. So your lab mentions it thoroughly that if you have where binary max, right, and other columns of that kind, you'll not be able to create. So one question is there. Let me just check it. If Synapse Analytics is available in all Microsoft, see, cloud has economics associated with it, right? Let us say Microsoft creates a data center in Antarctica. Will they do so? No, there is no business, right? So depending on demand cycle, cloud economics, the service would be there. And if you to check that, you can certainly go to azure.com and check the product availability by region, right? So you can check the Synapse, obviously, right? These are explorations that you can do. Okay, you should explore as much as you can, whatever you can yourself do, right? So you can pricing, right? So it is available in all these regions that you see over here, right? Synapse Analytics. So if you see, these are the valid regions in which Synapse Analytics is currently available for you to use it. Okay, fine. So other regions will not appear in which they are not there. Okay, fine. So it is cloud economics. If you go for master level courses in cloud, right? Let us say you plan that I want to become a master of engineering in cloud. The first semester will contain a topic called as cloud economics, right? So if you see cloud economics, the economics of scale. Mr. Warren Buffett, he's a very big name, Mr. Warren Buffett. What he says is that there are 1.8 billion Coca-Cola sold every day, Coca-Cola bottles sold every day. If you just increase the price of a Coca-Cola bottle by 1 cent, which is not very big for an end user, you are earning 18 million rupees every day. Economies of scale. Cloud is a very low margin business. That's why Microsoft entered this space late. Steve Ballmer, who was the CEO of Microsoft at that time, he created internally within Microsoft a vertical called as enterprise applications on services model. Enterprise applications on services model. Microsoft was already selling Windows Server, their Office product, and all the different things like SQL Server as an enterprise product. Steve Ballmer decided that we're going to have to sell them as services as well, right? We will sell them as services as well. So at that time, there was a principal architect at Microsoft called as 𝐊𝐳𝐨𝐰, right? He is the pioneer of Azure. Steve Ballmer didn't focus on Azure, which means it was at that time called as Windows Azure. He didn't focus on Windows Azure as that, which means in that detail. His primary focus was on mobile. You remember you to have the Windows Phone, Windows operating system. Steve Ballmer, his main focus was on winning the battle against Google. He wanted to defeat Android, but he was very late in that. But the question is that why was he not focusing on Azure, Windows Azure? Because it is a low margin business. Cloud is a low margin business. So when Steve Ballmer had few failures, which means obviously he failed in the mobile, so he had to resign. You know that, right? He resigned. And when Mr. Satya Nadella came, he hit refresh. He then wrote a book, hit refresh. And he shifted his primary focus to make Azure as the main business line of Microsoft. Even though it is a low margin business, how to make it highly profitable is the work of CEO, Chief Executive Officer. So Synapse Analytics, where it will be available, has a very large story behind the scene, right? Okay. So every service will only come in that region where there is money, right? If there is no money, it will not come. Let us see that. So create table, obviously, partition the column store. Remember about the partitions. Okay, when you created the partition, range right for value, generally for time. Distribution, you have already seen hash replicated as well as hash replicated and round robin. The type of indexes you have already studied: clustered column store index, clustered index, non-clustered indexes, and so on and so forth. Some sample questions: you have a partition table in Azure Synapse Analytics, dedicated SQL pool. You need to design queries to maximize the benefits of partition elimination. What should you include in the transact SQL queries? You have to design queries to maximize the benefits of partition elimination. Partition should be eliminated. This question needs more writing. The where clause must contain the partitioned column. If that is there, then we can use the where clause, right? Then you can use the where clause. You have a partition table, dedicated table, partitioned. You want to maximize the benefits of partition elimination. One more sentence should be written. That is, the column that should be used for elimination must be the partition column. If that is true, we can use the where clause, right? You use the where clause. That's it. If you use the where clause and the predicate of your where clause is filtering on the basis of the partition column, good to go. It will maximize the benefits of partition elimination. Now let us quickly come to the design the serving layer, and let us quickly finish out this thing. When you design your data warehouse for serving, you can either go with a star schema where you will have a central fact table, and then all the dimensions will be referring to the fact table through foreign key. That is a referential integrity. And all your dimensions will be fully denormalized, right? And you have to be aware of the concept of a business key, the concept of surrogate key, the concept of alternate key. Okay, that this was earlier in the course, but this is now removed from Microsoft, and you're not gonna get a lot of questions from this, but be aware of the star schema also. You're gonna have a Snowflake schema as well. The problem of star schema is that the dimensions are very bulky over here. They are highly denormalized. Very bulky dimensions are there. So to reduce the bulkiness of the dimensions, you could break down the dimensions by partly denormalizing them. But obviously then the joining cost will increase, right? But that is not a problem. So if you have storage on your mind rather than performance, then you can go with a Snowflake schema where you can say that my dimensions are now partly normalized, partly denormalized. That will help me reduce my space needs, right? But here the cost of joining will be high, because when you probe any dimension, you're gonna have to go through multiple dimensions to probe that. But nonetheless, Snowflake schema is also one of the most prevalent schema in the data warehouse design in the Kimball model, right? When the dimensions data change, it has to be reflected. In your OLTP system, if you observe, the OLTP system that we have, transactional processing system, we generally do not maintain the history in that. Nobody maintains the history in an OLTP system. Whereas in an OLAP system, history has to be maintained, that how the data changed, because the OLAP system answers the questions by comparing it to past, year on year, quarter on quarter. So what was the data before a quarter? I should know. What was the data before this quarter? Historical needs are there. So when you have historical needs, you can go for SCDs, slowly changing dimensions. Type 0, which means it's an implicit column. It does not need any kind of slowly changing dimension. Type 1, which means you basically do overwriting. Type 2, SCD type 2, you maintain a separate row over there, which tells us the beginning and the end, inserted and the modified date. And then it basically gives us the value. Okay, the new value. And you have type 0, type 1, type 2 up to type 6. Okay, slowly changing dimensions. Again, there were labs on it in the previous courseware from Microsoft, which implemented type 0, type 1, type 2. And if you go to the knowledge center of your Synapse Analytics, by now you should know where it is, knowledge center of Synapse Analytics. There, Microsoft have automatic pipelines for you. You can experiment with them. Delta loading is again a very important concept. Delta loading can be done incrementally. Incremental loading, this is what happens once the initial data warehouse has been created. So when you have created the data warehouse, you will load your data warehouse either using polybase or copy statement or some pipeline. But once initially the data warehouse has been created, then every week or every day or every month, you may be running a incremental loading cycle. So whatever new gets inserted into your OLTP system, or whatever gets updated in your OLTP system, that you will either newly insert in a OLAP system or again update in the OLAP system, right? So for that, you can do watermarking on the columns. So if the column value changes, its watermark will also change. So if its watermark changes and you compare that watermark with already what you have in your OLAP system, that says that some update has been performed on it in the OLTP, and that row you can take and overwrite over there. That will become type 1 writing. Or you can take that and you can write another row that will become type 2 writing, right? So be aware of delta loading as well. Delta loading from SQL DB can be done using the system change number, can be done using the system change version. It can also be done using the CDC capture, okay, data capture technology. So your temporal tables in SQL DB, they maintain the system change version of the row. So if you look at in the sys.change tracking tables, you will see that the system change version will change for tables who are newly inserted or the tables whose value has been updated. So when that happens, that tells you that, okay, the table has been updated. Some sample questions quickly for you. What are some quick questions? Replicated table. Okay, understood. Replicated table is a great fit. Okay, not a good fit. Not a okay fit, great fit. Okay. Now, so these points are aptitude. Great, good, okay. They're saying great, which means it has to be one of the best solution. Is a great fit for small dimension tables in a star schema with less than 2 GB of storage after compression. Absolutely true. If your table is using Columnstore archival compression And after using Columnstore archival compression, if the size of the table is less than 2 GB on the storage, then it is good to be a replicated table. It can go into the RAM of the compute nodes. You can put it into the RAM of the compute nodes fully. Okay, no problem, right? So that is true. Yes, you can take it. Again, it is not that this question will come in your exam. Point is, you're gonna have to develop again analytical skills. So whatever you have studied in your labs, read it thoroughly, read your book thoroughly, and develop some analytical points. You can make notes. Why are you taking those decisions? What is the reason, right? And mark appropriate answers. Implement physical data structures, partitioning the Azure table storage. We discussed it with you, right? What is the partitioning? How we do partitioning? So partitioning is done in the Azure table storage on the basis of the row key and the partition key. There are two columns in Azure table, that is partition key and row key, that is mandatory to be supplied. And that's how partitioning occurs in the table. The unique value of your partition key and row key is the composite primary key of the table. This is a very frequent question in data engineering exam, is DP-203. That is, the partition key and the row key is the composite primary key, and on the basis of them only Microsoft does the partitioning. But the unique combination of partition key and row key is the composite primary key. Here you can see the partitioning is happening on the basis of the, so the partitioning key is this, right? We are using this. The question certainly is that partitioning is done on partition key, that is fine. But what is the composite primary key? So they're gonna trick you. What is the trick? They're gonna say you this is the partition key, and then they will ask you what is the composite primary key of this table. So you will mark same, you will say partition key is the composite primary key, but no, the combination of the row key and the partition key is the composite primary key. You can have different kind of shard maps, right? This is slightly coming out of our coverage, but you can have list shard map where you have the shardlet key 1, shardlet key 2, and this is the global shard map manager database which has the knowledge about the shards that we have. And then there are shards which maintain the data for a single shard key. Okay, so here you can see shardlet which is holding the data for tenant 1, that is key 1, and this is holding it for key 2. Each shardlet will contain a data for just a single key, and this can basically be used for multi-tenant applications. So if you have multi-tenant applications, this kind of sharding pattern is good for them. Another kind of sharding pattern that we can leverage is called as range sharding. And here we can maintain the shards, shardlets of multiple keys in a single physical shard, right? So it can be a range shard. So shardlet range 1 to 3, shardlet range 10 to 11, we can basically maintain over there in multiple tenants, 1 2 3, 1 2 3, 10 to 11, we can maintain, right? These can be for customer profiles, I would say, right? So whatever the different customer profiles are, depending on the same customer profiles, right? Bronze, gold, silver, you could manage them, the same customer profiles in a single shard, so to say, right? Range shard mapping. So I'm gonna go quickly now and going to discuss with you the rest of the topics, right? So please be aware about the different replication types of your storage account: LRS, ZRS, GRS, RAGZ, RAGRS, GZRS, RAGZRS, and what level of resiliency they provide and how do they distribute your data. For instance, that is ZRS distributes your data into multiple availability zones, and they maintain 3 copies. So what is the meaning of presenting this slide is that please understand replication control is very important. LRS will give you fault tolerance, ZRS will give you high availability, and GRS, GZRS will give you high availability and disaster recovery. And GZRS will give you the highest level of resilience, okay. Geo-Redundant Storage, as we know, will copy your data into a secondary center, into the secondary region, and this is good if you want disaster recovery. And you can optionally also opt for RAGRS optionally, which means you want read access to secondary copies when the primary copies are alive, right? So if your primary copies are alive, then also you want read access to the secondary. This has been very frequent question in the exam. Do you know? Very frequently Microsoft asks this in the exam, in their solution architect exams, in data engineering exams, again and again. There are some workloads like consistency checkup for backups, summarization statistics, right? Long-term archivals, they should be done to a RAGRS account. Okay, so if they say you that you have a workload that needs summarization, there is a workload that needs uh, consistency checker for the backup files, don't do it on a primary copy, read write copy, do it on the readable copy. So then you would need RAGRS. Remember about GeoZone, your primary copies will become GeoZone redundant. Okay, so whatever your 3 copies were there, the primary copies, instead of being in a single data center, they will now be in a separate availability zone. This increases the resilience of the primary copies, and primarily why Microsoft brought it was they brought it just a year ago, right? Why it was brought is for disaster recovery scenario, for backups and site recovery and recovery services vault. So when we create our RSV, recovery services vault, and internal backup operations, we generally perform them on the highest resilience storage accounts, that is on the GZRS format. Okay, so if your question contains any hint where they say backup and restore operations have to be highly performant, high resilience of recovery processes must be there, highest resilience of blah 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 must be there, that is an indication that you are hinting us towards GZRS account. Okay, and these are the small points that eventually take you to upper levels of the score, right? Well, that's how Microsoft assesses people, that to what granularity level they know Azure platform, right? And when you know Azure platform at a very crude level rather than at a granular refined level, right? Quickly continue, slides are very high, so I'm going to give you a hint towards the exam and move it forward. That's what you see this. Why did this brought it here? Why did archive on-premises data to cloud came? Because if you read the standard documentation of Microsoft, you will see that whether you use native Azure backup technology or whether you use any kind of a third-party backup solution like that of your VM or what Acronis, whatever you use, right? A blob store is used, and when a blob store is used in such a scenario, that blob store has to be GZRS. Quickly, few questions that are at your disposal. Your company is making use of an Azure SQL database. The database comes under heavy load during last month of the year. You need to manually scale the Azure SQL database during this time. Which of the following would you implement for this requirement? Make use of elastic pool, make use of sharding, increase the DTU, decrease the DTU. So you know that increase the DTU levels, right? So now this question has nothing to do with Azure SQL database. This question has to do with your understanding of platform as a services. Azure SQL database, Cosmos DB, Synapse Analytics, Azure Data Factory, all of them are PaaS services. So we know that in Synapse Analytics, we have DWU, Data Warehousing Unit. In Data Factory, we have integration unit. In Cosmos DB, we have request unit. Okay, true or false? So this question is simply asking that when you configure these services, you configure those things. When you have to configure here, what will you configure? So the only valid option that seems over here is C, increase the DTU level. And then DTU levels come under standard, basic, standard, and premium. That they are not asking. They're just testing basic knowledge, right? You may say Azure SQL database was never covered in this course. This is not pertaining to Azure SQL database. They could mention it over there, service X, right? Does not matter. DTU level, right? So what again I want to highlight? General pattern of knowledge, right? General pattern of answering questions, right? Your fundamental base of the understanding would also be very beneficial for you. Implement logical data structures. Temporal tables are very important. Even though we didn't talk about them, temporal tables help you maintain the historical tracking, schema evolution. Data analysis will be very easy on the basis of the time snapshotting. It has out of the box immutability of historical data. We generally don't want anyone to change the historical data. That is called as cheating, right? You are trying to forge the history, right? So that is not allowed. Okay. Historical retention can also be done. As I already told you that there will be 6 type of SCDs. Don't take any headache about them, right? This is a part of graduate level courses. If you go for data oriented master programs, there you will understand all 6 of them, type 0 to type 6. And believe me, this is just a small set. There are 100 types of SCDs, right? This is just what industry implements. There are research SCDs also on which professors research, right? So this is only a brief subset of it, type 0 to type 6. Generally, you will end up using type 2 or type 1. These are again the combinations of type 2 and type 1. So if you combine type 2 and type 1, it becomes, I think, type 3 or type 6. I have to check it, obviously, because, okay, so this is the thing. Type 0 is basically column that is already known, implicit column. Other columns that are not implicit may go with type 1 if you want to do overwriting. So if you do overwriting, you are not maintaining history. That becomes OLTP system, right? So if the historical data is not of your significance, go with type 1. For type 2, you will have inserted date, modified date, and the new row with a surrogate key. So you will maintain the history that how rows are changing for the same individual, right? So you're going to add a new row for the new data type, which means new data type 2. We also understood that you will be creating external tables. Okay, they are metadata representations and they are a part of logical data warehouse. External tables. Be extremely be aware of the set as a statement, create table as select statement, because they ask you very frequently that thing, create external table as select. So please be aware about that. Please be aware about the please be aware of the full process. That is, you're going to have to author external file format, external data sources, and then eventually the external tables, and then do the reading in the round robin table, then create a replicator and the hash tables out of it, right? And this you will do through poly-based technology. One more technology does this, but it was not covered as a part of this course, which is a research topic that is called as a Parquet Direct, right? So yeah, so our course only discusses poly-based on this side of the things. A quick question for you. Here you can see a question. A company wants to add new table. You can see the question says a new value to a table. Okay, they want to add a new value to a table, and they have said they require old value for analysis. Oh, you want to maintain the history. Okay, customer wanted us to deliver on this address a month ago. Now he wants us to deliver on this address. Your OLTP system that records the transactions and the invoices, it is using the new value only, and it is also maintaining the new value in the table. But when my CEO will ask in which cities our business have increased, I need to know that this individual was asking us to deliver in the city one month ago and now in the city in this month. So I want to maintain history. Very reasonable, right? So he is saying that when you maintain this data about where is the new address of this customer, maintain his old address as well as the new address. They want to add a new column for all new value. Oh, they are not saying add a new row, they are saying add a new column, sir. This question is slightly tricky. This is type 3. This is not type 2. They want to add a new column for all new value that is to be added. Which type of SCD to be used? This is type 3 SCD, right? This is not type 2, neither it is type 1, neither type 3. Type 3 SCD, right? Let us see what answer it is. Type 3 SCD. This is a type 3 SCD. If you say add a new row, it becomes type 2. And if you say add a new column, it becomes type 3, right? It is a type 3 SCD that you want. Okay. Generally, if you don't want to go into too much depth of it, you can currently only remember that if you do not maintain any history, that is type 1. If you maintain a history in a new row, that is type 2. If you maintain a history in a new column, that becomes type 3. Serving layer, again, these things are coming. You have dimensions, and then you have the fact table, and one dimension may have multiple representations in the fact table, which means multiple rows may be mapped to a single row in a dimension table. All your dimension tables are fully denormalized. The space requirement for dimension table is very high, but the joining cost is very low because you only have a single table. Parquet format is extremely crucial for you. They're going to ask you partition, they're going to ask you Parquet format and Avro format. Okay, that when will you use that? Okay, so always remember that Avro first of all is row oriented, Parquet is columnar oriented. First point. Avro is good for binary JSON streaming format. Okay, in your question, if they tell you that, hey, we have some kind of a JSON structures that are getting streamed, in which format would you like to ingest them, in which format would you like to process them, full stop Avro, right? And Parquet is very good for heavy reading, heavy analysis, right? And Databricks company has invested millions of dollars to basically make this Parquet format the standard format of big data analytics. So that's why you see this roaming everywhere, Parquet, 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 Parquet. But others are also there. Databricks has done heavy investments in optimizing it, developing it, the Parquet format. Okay, remember about the Parquet format, how you author Parquet datasets in the data factory and in Synapse pipelines will be of very heavy value to us. Okay, Lambda architecture, very important architecture. Lambda, if you look at the Greek letter lambda, how it is written, right? So if you see the Greek letter lambda, right? So if you see this, how the Greek letter lambda is written, then you'll be able to understand this. A single stream of data is handled across two parallel paths, and either one of them may be live or both of them may be live depending on the investment of the organization. So there is an identified data source which we could process in parallel in both stream as well as batch. Stream will give you live analytics on it, fresh analytics on it, real-time analytics on it. Take decisions on fresh data. The person has gotten a heart attack. This is his this is the stream of his pulses. Right? What could you know immediately from it? that can help you understand the fatality of this heart attack. So a doctor will quickly ask you, give me the electrocardiogram of this quickly as soon as possible. And he's gonna quickly tell you by looking at those numbers, is it in a lower ventricle or is it in an upper auricles? So if the heart attack is in the lower ventricle, it is more fatal than as compared to the upper auricles. Live on the fresh data you give me quickly, the insight. And later he may analyze that if it was in the upper auricles, right? What were the other effects of it on the other organs like the pulmonary system? For that he may batch the data, batch it for at least 24 hours, for at least 48 hours to do more analysis on it, right? To understand better about it. Lambda, right? So you should be aware about it, right? So if you look here, new data will be there. We may plan to handle it parallelly into the speed layer, which will give us a real-time view very quickly. And we may also develop a master data set, which is a single source of truth in the batch layer, using which we will do some batch view. And the batch view is pre-computed. Why it is pre-computed? What you are gathering, the analysis that you are gathering in the batch is 24 hours old. It is not live. It is telling you what happened with this patient 24 hours ago, right? The patient might have already recovered, but the data tells you that he is under the massive heart attack, which is on the lower part of the ventricles, right? Speed layer. Now, speed layer will have all the hot services. Whatever the hot services that you studied will be falling under the hot layer, speed layer, Cosmos DB, 10 to 15 millisecond response time at the 99th percentile of the queries. So where will it be used? And so if a person just knows the basic of a service, he will be able to answer questions. Why Cosmos DB is getting used over here as a master data set creation tool? Cosmos DB is a hot data store, 10 to 15 millisecond latency at the 99th percentile of the queries. Cosmos DB also has a change feed for its transaction log, which is maintained using the metadata 𝐷 and the TS value, which gets appended to every document item in it automatically by Microsoft. And you can also use Spark structured streaming for processing, okay, in the speed layer. In the batch layer, the same master data set can be used by you, which has been developed in the Cosmos DB. In the serving layer, we should use some kind of a static structured source, but nonetheless, Cosmos also suffices the purpose because Cosmos has a table API in it, okay, that can act as a structured store to report from. So the significance of these slides is not merely to tell you that there is something called as batch and then there is something called as real time, but to appreciate why you are doing it, how you are doing it, what are its components like speed layer, batch layer, serving layer. There is a single source of truth that is a master data set. Apart from it, the questions that you should ask as a data and AI solution architect or a data engineer is, what services I will end up using. Think of it, right? Here we gave you one template, Cosmos, right? Spark, Synapse, table API of Cosmos, data lake. So think about it, okay? Develop your knowledge, thinking, okay? Analytics, that's it. Quick questions. You're designing a data processing solution that will implement the Lambda pattern, okay? The solution will Spark running on HD Insight for data processing. You need to recommend a data storage technology for the solution. Storage technology. Which two technologies will suffice your purpose? Should you recommend? What do you think? What should you recommend here? See, looking at whatever the question is, it becomes more an aptitude question rather than a totally perfect answer question, which means this is the correct answer and that's it. No, it's not like that. This question can have multiple answers depending on the use case. First of all, Spark running on HD Insight. So looking at this, we believe that they are using Spark over there for HD Insight for stream processing, because none of the option over here is any kind of a compute technology for stream processing. Cosmos storage, service bus storage, storage queue storage, Cassandra storage, Kafka HD Insight is for ingestion. True or false? Ingestion using the Kafka cluster and Kafka topic and the subscriptions, Kafka subscriptions. So these people are running Spark on HD Insight for real-time hot layer. So they need an ingestion point for that. So Kafka HD Insight will be in my answer. Another competing answer for it can be Azure Service Bus. Another competing answer for that is Azure Service Bus also. But I'm not gonna select that because the specific knowledge that says HD Insight, I'm gonna go with Kafka HD Insight as one of the option. Second option for storage technology has to be recommended, and that neither storage queue would suffice nor the bus would suffice, neither Apache Cassandra will suffice, because Cassandra I will end up using if I have proprietary needs. I'm gonna use Cosmos Cassandra API for time series analytics. So you see that you're gonna have to think in this manner, right? Rather than just knowing, okay, this is the right answer. Okay, give the reason. Other options are equally valid. Azure Service Bus is an equally valid answer for ingestion, right? But I'm not gonna use that because they're already running on HD, so why not run Kafka over there, Kafka cluster? So let us see what the right answer, right? So as per the general answers, ingestion of a stream will be done by Kafka, and the hot master dataset in the batch layer, we will use Cosmos.
So guys, if you liked our video, then do give us a thumbs up. But if you really want to learn more about the particular topic we discussed, then we have something really special for you. We have our free class on Microsoft Azure Data Engineer certification, that is DP-203, along with some question and answers, where we'll be discussing about why is everyone working on data, importance of some Azure services you should learn, and many more things. So for that, all you have to do is just log on to k21academy.com/Azure DE02, and after that you'll be seeing a screen like this. Just click on book your free seat now. Select your event date whenever you're available. Reserve your spot by adding your name, your email address, and your phone number, and you'll be getting all the updates via mail. You'll be seeing this kind of window on extreme right, so you can save this link, add to your calendars, and I'll see you in the free class. Till then, keep hustling and take care.